Hello everyone, this is a quick video on how to power an LED. So you might have seen LED circuits looking a bit like this. Maybe there's a 5-volt supply voltage, a resistor, and an LED connected to ground. What's the point of this resistor? Well, the resistor is used to limit the current which is going through the LED. So if we look at the volt drop here, there's actually going to be a voltage drop on each of these components, and these are going to add together to equal 5 volts, which is our input. And how do we select a value of the resistor? Well, we want the voltage of the resistor to be 5 volts minus whatever voltage is across the LED. And we choose this value by looking at the datasheet of the LED and looking at its IV characteristics. So we'd have voltage on the x-axis here and current on the y-axis. The graph might look a little something like this. And let's say we want to run 20 milliamps through it. This would correspond to a voltage to get 20 milliamps to flow through it. So this might be, for example, 2 volts here. So if we've read these values off the IV graph on the LED's datasheet, obviously it will vary depending on which LED you've chosen. So you'll need to look that up. But we can read that to get 20 milliamps, we need to apply 2 volts across it. So we can fill this in as 2 volts drop across this LED. That means that the resistor here will need to be 3 volts because 2 plus 3 is equal to 5, and they need to add up to 5. So if we want 3 volts to drop across this resistor, we can choose a value of resistance which gets us 3 volts. So we know from this curve that 20 milliamps is going to be flowing through this LED. And because the LED and the resistor are in series, that means that 20 milliamps is going to be flowing through the resistor as well. Now, using the simple Ohm's law, so voltage equals the current times the resistance, we can work out the resistance by rearranging this equation. So R is equal to the voltage divided by the current, which is equal to 3 volts across the resistor. And how much current is going through the resistor? Well, that would be 20 milliamps. Okay, so I've got my calculator up here, and what we can do is enter this 3 divided by 0.02 because it's milliamps, and click enter. 150 ohms. So this right here is equal to 150 ohms. And there we go.